take a look at this problem. And we got f of x is equal to 4x squared plus 4x plus 1. X is less than negative 1. I got all excited in the previous problem, putting in the exact right form, specifying the domain. I looked in the book and they didn't go to that kind of depth, so I'm not going to go into that kind of depth in this problem. First thing, though, I do want to do is I want to put this in a standard form. You're going to have to complete a square at some point anyway, so you might as well go ahead and do it. Now, the steps for going from general form to standard form. Step 1, you factor the number that's in front of the x squared from the first two terms. So I'm going to factor out a 4, and that's going to give us x squared plus x. Step 2, we're going to take the number that's before x. The number that's before x is the invisible 1. You multiply it times a half, and you square it. It's always times a half, and it's always squared. So that gives us 1/2 squared, or 1/4. You then not only add that inside the parentheses, but you subtract it. So we're going to have plus 1/4 minus 1/4. Now step 4. You want to factor the first, step 4. Let me see, step 1. Factor out the number that's in front of your x squared. Step 2 is what we just did. Step 3. Knew that sounded wrong when I said it. You want to factor the first three terms. And those factor as x plus 1/2 squared. So again, what I did is I factored the first three terms, these right here. Now there really is no factoring. There's a trick to it. Whatever number's right here, sign included, is always what goes right here. This was a positive 1/2, so that's why that's a positive 1/2. Now step 4. Multiply the number that we factored out in step 1 times the first grouping and then the number. So we're going to take 4 times x plus 1, or x plus 1/2, I should say, squared, and we'll take 4 times negative 1/4. So I'm multiplying the 4 times this factored piece and times the number. So that's going to give us 4 times x plus 1/2 squared. These 4's cancel, and I got negative 1 plus 1. So then negative 1 plus 1 cancels. That's interesting. Let me double check myself here. Okay, factor the 4 out. 1 times 1/2, 1/4, 1/4 I added. Okay, factored. Okay, multiplied the 4 through. Okay, that all looks correct. That threw me the x less than negative 1. Usually that matches the number that's inside the parentheses here. It doesn't have to. If it had been greater than negative 1/2, then we would have had an issue. It wouldn't be a function that we could find the inverse of, because it wouldn't be 1 to 1. Okay, so this is still the conditions on here. X is less than negative 1. That hasn't been dropped. So now to find our inverse. Step 1 of finding our inverse, replace f of x with y. Step 2, interchange x and y, swap them. So we got x is equal to 4 times y plus 1/2 squared. Step 3, solve for x, or solve for y. So divide both sides by 4. Those 4's cancel, and we got x over 4, or 1/4 x, depending upon how you want to write it, y plus 1/2 squared. Now square root property. If we got something squared equal to something else, you drop your squared, and you put a plus or minus square root around the other side. Well, we can't have a fraction inside of a square root, even though they allowed it in the last problem. They might in this one too. So I'll split this up. I'll put a square root on top, a square root around the bottom. So then we got plus or minus square root of x, and square root of 4 is 2, equals y plus 1/2. Now take the 1/2 over, it becomes a negative 1/2, plus or minus square root of x over 2 equals y. Now we got the same denominator, so I'll merge them together. And while I'm at it, I'll go ahead and put my inverse notation in there. So we're going to have negative 1 plus or minus square root of x over 2. But we got a problem here. You can't have a plus or minus. Now remember our original domain. X is less than negative 1. Well, for our inverse, that swaps. That becomes y is less than negative 1. Well, if I think about this and how it'd work out, let me see, it's got to be less than negative 1. So if I add something, like if I add 10, negative 1 plus 10 is 9. 9 over 2 would not be less than. So we want to keep the minus. So we're going to have negative 1 minus square root of x over 2. And since they didn't specify the domain on the previous problem, I won't worry about it here. Let's see if that's a true statement. Negative square root of x plus, or they put negative out in front. Okay, well, that's preference. X is greater than 1. Oh, they did specify it. Okay. Now, where that comes from, you might say, well, I thought square root of x, I thought you set what's underneath the radical and you set it greater than or equal to 0. So shouldn't it be x is greater than or equal to 0? Well, not necessarily, because up here we come up with y is less than negative 1. After we put this in the standard form, what this means, when you got your number inside with your x, actually I should have went here. It shifts left or right. So this tells me that it's going left. So it shifted left 1/2 units. Well, if you think of your parabola, that's a U-shaped graph. It's left 1/2 units. It would look like this right here. Well, if I follow their convention and factor out that negative out in front, then this becomes square root of x plus 1 over 2. And when this is left 1/2 units, if I think about the range, your range is going to be 0, comma, and then the positive infinity. So normally we'd say, well, that's our domain. Our domain is got to be from 0 to positive infinity. But if we look at our range was y is less than negative 1. And if I were to put 0 in here, we get square root of 0 is 0 plus 1 is 1. That's negative 1/2. And we're specifically saying it's got to be less than negative 1. So that's why in their answer they say x is greater than 1. Because if I put 1 in here, square root of 1 is 1. 1 plus 1 is 2. 2 divided by 2 is 1. So that's where you get this at. A little bit tricky on that. Remember, initially I kind of stopped, and I had this domain here, and I said usually it somehow ties to this 1/2 right here, and it didn't. So that's where you have to really examine what value can I put in there such a woodwork. Though it is curious that they specified a domain on 14 but didn't say anything about 12. So it's nice if books are consistent, but it's not always the case.